most welcome to today's ProDev Hour. We would like to start this day by giving it to the Lord. May I request Miss Oliver Achakara to give us an opening prayer. Miss Oliver Achakara, please give us an opening prayer. If Oliver prepares, may I request Oto Bonnie. Bonnie Oto, give us an opening prayer. Okay, members, let us pray. Yes? Let us pray, members. God, our loving Father, we thank you this evening for bringing us safe to this meeting. We pray that, Lord, you will give our attention to the meeting. May all that we are going to discuss, Lord, be for the glory of your name. May all the wisdom that we shall gain here be for the benefits of the learners and for ourselves. And may all those who are yet planning to join, Lord, you help them access. I pray that you be with us from the beginning to the end of this discussion. Believing and trusting you have heard us through Christ our Lord. Amen. Members, you're most welcome to this meeting. Today's ProDev Hour is yet another great day that we are going to discuss a very important topic. We are privileged that in the previous weeks we have been discussing how, as teachers, we are able to make schemes of work. By now, I'm very sure that we are aware of the elements that we need to include in our scheme of work to fit in the competence-based curriculum. The following week, we were also able to see how we can make an effective lesson by making a very good lesson plan. And we were able to discuss in depth how to make the lesson plan to fit in the competence-based curriculum. We are yet grateful this evening, members, to have yet another great presenter from National Curriculum Development Center, who is coming to discuss with us a very, very good topic on how we are able to infuse generic skills in the teaching of sciences. So after looking at the schemes of work and lesson plans, how do we bring in the generic skills so that the learners are able to learn effectively? And this evening, we are blessed with our specialist of biology at National Curriculum Development Center. This is none other than Mr. Jude Agaba. May I welcome him warmly to today's ProDev Hour. Mr. Jude, you're welcome. We are at your hands. We are here to listen to you as you share with us. Most welcome, sir.
Thank you very much, Betty, for the wonderful introduction and again giving me the opportunity to make a presentation to UPSTU. I feel honored and blessed to make this presentation today. and I hope it will be of benefit to the science teachers who are here on this platform, but even to all other science teachers out there. I would just want to confirm if you can hear me before I continue with my presentation.
Please, you are loud and clear.
Thank you very much.
Okay.
So my presentation is on the infusion of generic skills in our curriculum, and it is something that's very important for teachers because when we go out to the field, there are many teachers say, hey, the syllabus is saying we use generic skills, but how best can we do it? So my presentation today should help to address that one. So again, we're going to listen to how we are going to infuse generic skills in the teaching of sciences in our schools. I just want to confirm if you can see my screen.
Yes, the screen is seen.
Okay. So generic skills equip learners with the ability to adapt to change and navigate life challenges in the 21st century. So as we teach our learners, the syllabus has been very intentional on empowering our learners with specific skills which we feel are important, that these learners go out there, even when they're in school and out of school, they can be able to navigate the challenges that they meet in life in this century. Our syllabus for lower secondary school particularly set out 5 generic skills that would like our learners to acquire and live with when they finish their lower secondary. The skills are critical thinking and problem solving, creativity and innovation, communication, cooperation and self-directed learning, mathematical computation, and ICT literacy. So in other, maybe other books that you read or other resources that you might come across, they will name these as 21st century skills, others name them as soft skills. But the key thing is that these are skills which learners need to use while they are at school, but are important for their lives in school and outside school. I will not go into the definition of these skills. I'm going to dive deep into exactly how we as science teachers can infuse these skills in our teaching and learning. And I'm going to go through each skill step by step. We'll begin with critical thinking. Now, the syllabus has clearly set out under critical thinking, because critical thinking and problem solving is a broad thing, it's a broad aspect. But within that aspect, we can break them down into indicators. So what you see on my screen labeled as 1, 2, 3, will go up to 4 and 5. Those are indicators that show that the learner is actually is displaying that skill. So if you look at maybe number 1, plan and carry out investigations. If a learner is able to do this, that means this learner is a critical thinker and a problem solver. Now, for this particular indicator, and throughout my presentation, I'll give an example of where we as science teachers can infuse these skills and see that the learners are doing them. So if I am a teacher of science and I want to, for example, know that my learner is able to plan and carry out investigations, one of the things I should see the learner doing is design a step-by-step procedure, for example, to test how the concentration of acid affects the rate of reaction with magnesium ribbon, and then execute the experiment safely. Now, I have bolded certain letters that I want to put an emphasis on. Here, the learner is doing the design. So the teacher doesn't come and just say, now follow these instructions, get concentration, this add magnesium, and do all those things. No, it's the learner to design the experiment. What the teacher says is, we need to find out if actually the concentration of acid affects rate of reaction. Go and carry out this investigation. So if the learner is able to properly come up with a step-by-step procedure, and then after that carry out the actual experiment, then for you as a teacher, you will know that this learner is able to carry out and plan an investigation, and therefore is a critical thinker and a problem solver. Now, luckily enough for science, most of the work that we're doing now is following the scientific investigation process, which requires the learner to do the planning and then actually carry out the experiment. So this indicator of critical thinking for us, if the teachers are actually doing it in class, this is one of the core things about science. And we're going to see it appear even in other skills or other skill indicators. So in terms of critical thinking and problem solving, if a learner can design a step-by-step procedure for a particular experiment or an investigation, and then even actually carry out the investigation, that is an indicator that this learner is a critical thinker and a problem solver. Next, number 2, sort and analyze information. We also have an example where learners can measure the plant growth in different light conditions. And when they're doing that, they get data. And this data is raw. But if they can organize that raw data into a table, that means they are sorting that data. And that's a skill that the learners are acquiring. If you can recall well, previously when we do our old practicals, a table would already be set. They're already telling you what to fill in the table. So as a learner does an experiment, they just get their data and put it direct into the table. But now we're saying this learner goes out, measures the plant growth, records maybe on some notebook that they have in the field. They're doing that for a number of days, or yes, putting their raw data in a notebook. Now when they come back, now they organize this data well, create a table, and see how to place that information in a table. That is what we call the sorting. Then eventually, once they sort, they can come up with, for example, line graphs, and use those line graphs to determine the relationship between light intensity and height. Now, this determining the relationship is what we call analytical information. Sorry. So they're able to sort first and then to analyze. By the time the learner draws the graph and then explains the relationship between light and growth, that means the learner is analyzing information. And if they can do that, that means they're displaying the skill of critical thinking and problem solving. A third one we can look at is identify problems and ways forward. So if a learner is doing a physics practical and somewhere along the way they have connected their circuit, everything is there, but the bulb in the circuit fails to light. So what the learner does first is to check, maybe for loose connections, check whether the batteries are old and they're depleted. Now, what they're doing in that case is identifying a problem. So they're trying to find out, why is it that the bulb, my circuit, I've put the switch on, bulb is not lighting. What's the problem? So they'll check the connections, see if everything is ever in place, check the batteries, see if they're okay. Now that is identifying the problem. Once you've identified that maybe it is the batteries or one of the wires is not working, then the learner goes ahead and replaces the item that's not working, the item that's malfunctioning. And that means they have identified the problem and probably found a way forward to go about it. So if you are doing a physics practical and your learner cannot, the bulb is not lighting and they're not able to find out why this is happening, then probably they are yet to acquire the skill of problem solving. And it would be the role of the teacher to come in and say, you do what we call troubleshooting, do some form of diagnosis and allow them to do it on their own. You don't just come and say, okay, here are new batteries, start. No, let them figure out why this circuit isn't working. When you let them do that, then they will become critical thinkers and problem solvers. A fourth indicator of critical thinking is predict outcomes and make reasonable decisions. So the example we have here is those in chemistry know that if you have the reaction between zinc and copper sulfate, that reaction is exothermic. But you want the learners maybe to do some research before they do this experiment. And when they're doing the research, they'll find out that the reaction is exothermic, it gives out heat. So before they do the experiment, if these learners are critical thinkers, they would forecast and say, when we add zinc to copper sulfate, because the reaction is exothermic, we are now going to decide to use an insulated calorimeter to accurately measure the expected temperature rise. Usually these experiments are used to determine whether the experiment actually is exothermic. But if they have read and they're critical thinkers and they know that maybe using a beaker, the experiment is going to lose heat to the surroundings. So what they do in this case is forecast, and that's predicting. They're going to say, when we add zinc, this reaction will lose heat, but we need to measure the temperature. So what do? They make a reasonable decision and decide to use an insulated calorimeter so that when they measure the temperature, their results, they will get results with little or minimal error. So once you see your learners doing that, coming up with something like that, they are critical thinkers. They are able to predict an outcome and make reasonable decisions. And then the last one under critical thinking and problem solving is evaluate different solutions. For example, they can compare the effectiveness of using filtration versus evaporation to recover clean water from a salt-sand mixture. So their senior ones, you've taught them about separation of mixtures, and now you give them a broad task. You're like, now that you know these different methods, separation and mixtures, we have a salt and sand mixture. How best can we separate these two? So now the learners on their own should be able to say, let's try out filtration. They do it. They also try out evaporation. They do it. And then they see and they come up and say, okay, from our experiment and from what we have done, we feel that this method of separation is much more effective than the other method. And that means they're evaluating different solutions. So both methods can separate mixtures, but they can be able to come out and confidently say they will choose one method over the other. And that shows that these learners are critical thinkers and problem solvers. So for critical thinking, those are the 5 indicators, and we have looked at examples of how these indicators can be applied in our teaching and learning of science. The next skill is creativity and innovation. Many times people think creativity is only for the arts, and so maybe sciences don't have any space in being creative, but all learners, irrespective of their subjects, can be creative. and we're going to see how this can be made possible. So one of the indicators of creativity and innovation is use imaginations to explore possibilities. Again, I've highlighted an area of interest. They're saying brainstorm how movement on Earth would be if gravity were reduced by half. So in physics class, you can provoke these learners to say, we have learned about gravity, but now, what if gravity is half the force it is right now? Or what if it is twice, it is double the force? Now they start imagining and saying, if it's half, what would it be like to walk on Earth? And they start using their imagination to explore possibilities. How would we walk? What would we use? Would we need special equipment? etc. etc. And that is what we call creativity. They are thinking and using their imagination. Another indicator of creativity is they're able to work with each other to generate ideas. Members, when you're creative, some people are creative alone, but most of the effective creative teams work together. So they keep generating ideas together. So here the example they're giving us is learners work in groups. They collaborate to form a list of as many potential variables as possible that could affect the efficiency of a homemade wind turbine. So if this learner said maybe a project, we want to make a turbine, something that can generate electricity using wind energy. Now, if you want to know that these learners are creative, they would sit in a group and all the members of the group come up with different possibilities and say, if our turbine is to work well, we need to do A, B, C, D, E, F, G. That generation of ideas is an indicator that these learners are being creative. A third area under creativity is suggest and develop new solutions. So the example we have here is learners identifying that plastic waste is a problem in their society or in their school, and then they decide to design different waste management strategies. Many of our schools today are coming up with different ways in which to manage waste. And that is an indicator that these learners are actually being creative and innovative. So I've visited schools where learners make dustbins, they're making art pieces, they're making fences, they're making rugs, all sorts of very beautiful things out of plastic waste. So once you see that happening, and they can clearly explain to you that we've seen we have too many caveras, we have too many plastic bottles, we have decided to collect these items and form something new out of them. That is the new solutions. Then these learners are being creative and innovative. Members, I keep insisting that it's the learners who do this. So if a teacher says people collect all the plastic and then we make plastic bins, the creativity is not for the learner in that case. It is the teacher's creativity. So one of the roles the teacher has to do is allow the learners to go out there, think, and come up with these solutions on their own with very little intervention of the teacher. Once there's little intervention of the teacher, then you are building the skills of the learners. If we keep intervening and giving them the ways, then you're not building their skills. 4, under creativity and intervention, is try out innovative alternatives. So here we have an example of plastic cell holders also in physics. Physics in the lab, if you go to a well-equipped lab, you'll find there are cell holders which are already there. But we assume that some of the cell holders are not working. Can the learners come up with alternatives for a container to hold their cells as they make their circuits? And all of us know that one of the commonest one is using Once you finish a toilet paper roll, that cardboard that remains is a perfect example of an item that you can place cells in and then make your circuits in a physics practical. So if the learners can come up with that on their own, then they're showing you that they're trying out innovative alternatives, and therefore they're displaying the skill of critical creativity and innovation. And the fifth one under creativity is look for patterns and make generalizations. The example we have is they can observe properties and trends of elements in the periodic table and then propose household products that are a result of these observations. So if I see trends in maybe group one or group two, and I find group two that these are, sorry, group one alkaline metals, and then somewhere in biology we learned about bacteria in the mouth that create acidity, and now I try to ask myself why is Colgate talked about to be alkaline one and also contains maybe calcium and all these adverts that we watch on TV. So the learners, if they're able to look at those patterns in the periodic table and relate and make generalizations about, for example, household products that we use, these learners are showing that they're being creative and innovative. And that is something wonderful that we want to see. Before I leave, again, these things that I highlighted, observe the properties, propose household products. The teacher should take an intentional role to give the learners a chance to actually observe those properties. So you need to give them time to study the periodic table, look at it carefully, find out about the properties of all these elements, and then it's only then that they can propose things based on their observation. So each time we see something highlighted in this presentation, it's something that means this is a pointer for the teacher to determine what they would let the learners do. Another key generic skill is communication. Under communication, we have again 5 indicators. The first one is listen attentively with comprehension. And the example here given is learners take structured notes. I've put that in bold, and later summarize the speaker's main arguments during a presentation on renewable energy. So our different science subjects, we the teachers are able to invite different resource persons to talk about areas or topics within our subjects. And so when this resource person is speaking, if our learners can be able to create their own notes and even later summarize those notes, this learner is showing that one, they listened attentively during the presentation, and if they're able to summarize, then they actually understood and comprehended what the speaker was talking about. So here, there are two things. The teacher, if you're to develop and enhance the listening attentively skills, one of the strategies you can do is to invite different resource persons in different fields. Science has a lot of people out there who can talk, and they don't have to come from very far. You have to look within your community, invite these people to say something about a topic or a concept within your subject. If the learners can listen, take down their own notes, and even come up with a summary of those notes, that means they're able to listen and comprehend what was being said. That is an indicator of communication. For science, maybe I could also bring this in at this point, is that sometimes people want to restrict communication to speaking, but there are major 4 aspects in communication, that is speaking, listening, reading, and writing. Speaking, listening, reading, and writing. So when a person is able to do any one of those well, That means they are showing that they are good communicators. So the second indicator is talk confidently and explain opinions and ideas clearly. Example we have here is during a class debate on genetically modified foods, a learner articulates their position by citing biological concepts to support their viewpoint. What does this tell us as a teacher? More particularly science teachers, give the learners activities to do things like debate. Again, like I said at the beginning of my presentation, a science teacher would say, debate is for English language only. I can't waste my time. Or it is for the debating club. But here we are being given an example of a debate in a biology class, and we know if you're aware about genetically modified foods, there are so many contrasting views and points over use of genetically modified views. Sorry, genetically modified foods. Now, if you give the learners chance to debate, you're building their skills in talking confidently, explaining their opinions and ideas. And that is an important skill for the learners out there in the field when they leave school and even during school. And we as science teachers can be able to develop these skills. So as a teacher, allow the learners opportunities to do things like debate. You will be building their communication skills. Read accurately and fluently is another indicator. And here they are proposing a learner can examine a scientific article about climate change, correctly identify the hypothesis, methodology, and key vocabulary terms without hesitation. So most scientists at whatever level always publish their work. You as a teacher can give the learners a small article of a published work that is not too complicated for lower secondary, and then they read it. And if the learners read, and then you can see that these learners can be able to identify the hypothesis, methodology. These are things that we have taught them about scientific skills, but when they read the article, can they pick out these things? Therefore, you would know that this learner was able to read accurately and fluently. Under communication still, they're able to write and present ideas, produce a formal laboratory report, following a logical structure to explain their findings on osmosis. Those who are doing scientific investigations in class, one of the major things that your learners should do are to make a report, that's one, but also present that report. They should be able to come and go in front of class and present the report. So if the learner can make a report which follows the correct sequence, title, aim, materials used, procedure for the experiment, results, analysis, discussion, and recommendations. If they can do that, that means they are writing their work well. And then after that, they should be given an opportunity to present what they have done. I have attended a number of science fairs where these learners actually present work, but usually when they present work, they do it along with a written report of what they did, combining with what they're presenting on that day. So the learners who go to science fairs usually are displaying a skill of communication because they can show that they have a report. That means they wrote it and they're able to present their results. Then the last one under communication is use a range of media to communicate their ideas. Again, this is similar to number 4. Once they have written their work, they should be able to present their work in different ways. Some can use PowerPoint, some can use whatever methods to present their work, and the teacher should give them the opportunity to do that. If you give them that opportunity, it means they are developing those skills. So the example they're giving us here is create digital animations with an infographic to demonstrate the water cycle. So you give the learners chance to present their work. And now that we're promoting ICT integration, if they are using media to communicate, this could be one of them. For the schools which can afford, they can make videos and post them on whatever educational platform that they have for people to see what they're doing. Once you let them do that, you're building their communication skill. Another skill that is important in our work is cooperation and self-directed learning. Learners work effectively in diverse teams. Here they're saying investigate biodiversity of a local pond. The learners are let to go out in the pond and then see the different things that are there. But how do they do that? They allocate themselves different roles. Some are the ones who are organizing the equipment, others are the ones who are recording data, others are the others who are identifying plants, others identifying animals. Once you let them do that, they are going to get the skill of working effectively in diverse teams. That means different people doing different work. That all leads into cooperation. Again, if learners actively listen to a partner's logic, asking clarifying questions rather than interrupting their colleague. So if you give the learners chance to explain, maybe the learners doing some equation in mathematics and they're trying to explain some details, if the other partners are given time to listen to how this learner is explaining and just ask clarifying questions without interrupting. So they're interacting with each other, and that shows that there's cooperation. Taking responsibility for own learning lies under self-directed learning. Again, a learner might have been given a quadratic equation to solve. They did it and they were not able to get it correct. So they go back to their desks, maybe during prep or at home, and do the equation again. Identify any errors they made, and then record their progress in a self-reflection journal. So they go back, do the equation again, record how they are going through it. This last high bolded thing, the self-reflection journal, is important because the learner will say, when I wrote my first equation, this is what I wrote it, this is what I was thinking. But I discovered that ABC was wrong. Now I've rewritten this one. But to be able to rewrite this equation, I went through all this process. That's called a self-reflection journal. And that is an example of taking responsibility of own learning, which lies under self-directed learning. So I've highlighted this one as something that teachers can consider using. It's both effective for the teacher in their work, but we'll not talk about that, but for learners to be able to journal, write down. Journal means they get a 32-page book and they write down, this equation, I didn't do it well. I don't know why, but I think my problem was here and here. I have gone back and during prep, I decided to rewrite the equation, identified where I made mistakes, and now I think this equation is okay. I'm going to take it to the math teacher tomorrow to look at it. So that is what they mean by taking responsibility for own learning. Under cooperation and self-directed learning, there is also work independently with persistence. The example we're being given here is during conducting a titration, learners experience several overshots of the endpoints. Any of you who has done chemistry knows that when you're titrating, they are telling you to do dropwise, you press it, the chemical runs, woof, and the color changes very fast. So a learner who is self-directed will continue to try the experiment again and master the ability to do a drop by drop so that they can be able to, once that one drop lands into the conical flask and changes, and then they don't overshoot. I remember when I learned that one, I got very excited to be able to measure that one final drop that would change the color in the flask. It felt very satisfying. So the learner doesn't give up. They keep trying until they can see how best they can accurately get those volumetric titers. So that if the chemistry teacher allows the learners to do that, then you're building on their ability to work independently with persistence. Finally, manage goals on time. Many of our learners are doing projects in school today. Now, among the projects is, of course, determining how much time this thing is going to take. And so, if our learner can say, this is a project I'm going to do, it's supposed to last 1 month, but in that 1 month, I'm supposed to do 1, 2, 3, 4, 5 things. Those 5 things are usually the stages of the project. So they can sit down and set their goals and say, I want by week 1 to have done this, week 2 to have done this, week 3 to have done this, week 4 to have done this. That learner is showing that they are self-directed learners. So for those who are doing projects, you know how this works. They have to set their timelines. What am I going to achieve within those timelines? And then they work towards achieving that. So managing goals on time is one of the indicators of self-directed learning. And lastly, the final skill that is recommended by the syllabus is mathematical computations and ICT literacy. Again, for us as UPSTU, we are science and math. So we might assume that, okay, most of our work involves mathematics, but you need to consider other subjects, maybe what we call humanities, the arts, vocational. This is an important skill. The languages, this is an important skill that they need. Although the examples I'm using here are specific for science, but even the other people that are non-science need this skill. The first indicator under this skill is use numbers and measurements accurately. So this aligns with mathematical computation. So here they're giving us an example. A learner is determining the relationship between mass and acceleration. Then the learner uses a digital balance to measure a marble to the nearest one, 0.01 gram. So the number that they are looking out for is something that is very close to 0.01. And what are they using to measure? They're using a digital balance. So what does this tell us? When we are going to do, if we are going to bring out these skills in science, we need to give these learners all these different tools, the equipment that we have in the lab, provide it to the learners. Don't just stop at you demonstrating. Give the learners a chance to use all this different equipment. Let them use those equipment to do those measurements. But even as they're doing the measurements, they should be having specific numbers, figures that they're going to target to show that they're carrying out these measurements accurately. Interpret and interrogate mathematical data. Here, the learner notices a plateau and a temperature graph. So we have temperature graphs in biology, we have them in physics, we have them in chemistry. So they can look at that plateau, that's the line is straight, let me use a simple term, and then they will know that this line actually means something. So that's the interpretation. They can know that this thing, when the line in the graph is straight, how do I interpret it so it's straight? And when they see some changes, the line in the graph goes down, that's a slight dip, they should ask themselves certain questions. Was there something wrong with the measurement? Was it a result of environmental factors? Or again, was it just a change in the experiment? So they should interpret and mathematical data. Interpret and interrogate that one, then they're showing abilities in mathematical computation. Use mathematics to justify and support decisions. In chemistry, they're telling us if a learner was able to get 65% yield during the preparation of an insoluble salt, they can decide to change their filtration method, arguing that a more significant amount of product was probably lost during the initial stage. So in some of these experiments, learners can come up with certain mathematical results. Here they're talking about 65% yield of a particular salt. Then they should say, is 65% enough? Can't I raise it up to 95 or 90? And therefore, they are using that percentage yield to say, we need to do this experiment again and see if we can get a bigger yield out of this experiment. So that is an example of using mathematics to justify and support decisions. Again, it's the learner doing this. It is not the teacher telling the learner what to do. And they should argue out their reasoning in order to tell you why they're doing what they're doing. And the last parts of ICT are using technology to create and manipulate, manipulate and process information. Again, in chemistry, it is possible for you to use sensors to track pH changes during initialization reaction in real time. Then they can get the data that they have tracked, because that means they keep recording the pH as it keeps changing, maybe from acidic to alkaline or alkaline to acidic. They keep changing, noticing those changes. The sensors are now the digital tools. So there are tools out there that can do things like that. They can measure amount of moisture, they can measure changes in pH, they can measure different things. So the digital tool, they measure the changes as they and record. Then they take the data to a spreadsheet and then calculate the rate of change. So they use technology to create, manipulate, and process information. So if our schools can be lucky to have those digital tools that can do these things, then we are building their ICT proficiency. And then finally, you have used technology to collaborate, communicate, and refine their work. So assuming that this is a group of learners who are going to present at a science fair, they want to come up with a very nice poster, and there are different groups. There are learners in senior 1, senior 3, senior 6. They can use software and apps like Google Docs. So they are working on one document, but they're in different places to draft the poster. They make comments, they suggest edits, fine tune their work. This is how you'd show that they're using technology to collaborate. That means senior ones are working with S2s and S4s to come up with a poster, and then they can communicate and refine their work that they're doing. So again, I will still insist, what we're seeing here in bold are something that the teacher should look out for. How many times do our science teachers give learners chance to use Google Docs? Or do the teachers actually know how to use Google Docs? That is something maybe apps too can think about and think of ICT technologies and how teachers can use them. I don't know if they've done something like that, but if the teachers know how to do these things, then they can let their learners do them. And once you do that, then they're building their abilities. Right now, I'm making a presentation on Zoom. It is something that also a science teacher can say, no, my next lesson on, I don't know, whatever lesson you want it to be, we are going to do it on Zoom. And if they do it and can do it successfully, we don't have to wait for COVID to be here to adapt Zoom lessons. If the learners on their own can set up their Zoom, discuss about a science issue, then what you as a teacher have done for them is to empower them, making them more ICT proficient. Ladies and gentlemen, I beg that my presentation ends here about the infusion of generic skills in teaching and learning of science. Thank you very much for listening to me.
Oh, we are very grateful, Mr. Agaba, for this wonderful presentation on infusion of generic skills. Sincerely, without infusing generic skills in our teaching and learning processes, the process becomes meaningless. You have helped us this evening to appreciate that we really needed to understand each of these generic skills and how we are able to use it in our classroom situation. And above all, I want to appreciate you for giving very good examples during your presentation that personally it has helped me to really appreciate these generic skills. Many people, when they hear about generic skills, they do not want to believe that it is part of what they should do in the classroom. But through this beautiful presentation, me, I'm converted. I wonder if there are some people here who are not converted like me, or if you're converted like me, please, you raise up your hand here and we can share our feelings or questions you want to ask. I'm very sure Mr. Gaba is very ready to answer them. Members, you're welcome to share one or two things. Please use the chat button and raise up your hand. Or I can provoke. Can I provoke? Mr. Francis Etiang, if you're listening to us, do you have something to say on this presentation? Francis Etiang. Yes, members? Am I seeing you? Hello? Jacob Okello is the Deputy National Treasurer of Uganda Professional Science Teachers Union. I would love to hear a word or two from him. Welcome, Jacob.
Thank you very much. I must appreciate our facilitator today. Thank you very much, Mr. Jude Agaba. Actually, you have broken down the generic skills to manageable parts, so that even as teachers would wait for the indicators. You know, people think in generic skill you must teach it, but you must expose the learner, and then the indicators from the behavior of the learner. I think today you have broken it down to teachable parts. I'm very grateful for that. We shall apply it. You have made it now very easy. That's what my comment I can make.
Oh, thank you very much.
Thank you very much, Mr. Okello Jacob.
Invite Agaba for future, because the presentation is very nice.
It's noted, sir. It's noted, sir.
How to break down the learning.
Okay, thank
learning
you.
outcome. Learning outcome. We relate learning outcomes to activities of integration and so on. All this, we love you to come back and make more. But today it is very good. The presentation is very good. Thank you. I can stop there.
Oh. Thank you, Jacob, for this addition and appreciation. I am seeing here Mr. Amisa. Amisa, you're welcome, please. Is Mr. Amisa hearing me? Yes. Okay. Mr. Tumuhereze Edson William, welcome to sharing with us your feelings. Amisa is saying, I really do appreciate Mr. Jude for this wonderful presentation. Thank you very much. Can we hear from Tumuhereze Edson William? Very correct information. And when the teacher has been good, the learners pick it up on first hearing. And this is what we would like to say. Yeah, that is very true. May I invite you now to, maybe you have to say some concluding remarks before we can end this presentation for today. Jude,
Thank you very much, Margaret. Again, I'll say thank you all for those who were able to attend this presentation. And I thank all those who sent in their appreciations, Mr. Okello and Mr. Amisa, for appreciating what we have done. Again, my closing takeaway home message is these skills can be broken down to some simple bits. It's not a must that every skill has to be taught in a particular lesson. You can, as a teacher, try to focus and say, this particular lesson, I would want the learners to acquire this skill. So if it is working as a team, you focus and see that every learner in the group is working, collaborating, involved in that one, and you can see it grow. But my words that I would end with are that the teaching method, the methodology that you choose has a lot to play in learners acquiring these skills. So I encourage the teachers to vary your teaching methods, make them as much as different as possible. Those methods are the ones which determine how well your learners will pick up the skills that you intend to build in them. Thank you so much, Betty, and all who are here to listen to this evening.
Thank you very much, Jude Agaba. Yes? I want to say on behalf of Uganda Professional Science Teachers Union that we are grateful for this wonderful presentation and the time you people at NCDC gives to the people who are able to attend our professional development hour. We are very grateful that after this presentation, they have always visited our website to read this information. So we are sure that we are reaching over 15,000 members of this community, plus other well-wishers who always want to join us. This means that we are doing a great job. Members, your moderator this evening has been Madam Betty Auma, the National Secretary for Education and Professional Standards and Discipline of Uganda Professional Science Teachers Union. Allow me to take this time to make announcements and tell you that we, as Uganda Professional Science Teachers Union 2026, we have a project that is running on, and our closing date for submission of project innovations from the different schools has been today, and we expect that the vetting process is going to start, and after 2 weeks, we would be ready to announce the projects that will have gone through, and the schools will have to prepare receiving the invitation letters so that the competition can kickstart sometimes to come in June. I want to wish all of us very well, very, very nice this evening. As we have the holidays, please let us keep on this professional development hour, because we are ready to bring you very good topics. And next Thursday, we're going to have yet another presenter from National Curriculum Development Center coming to help us look at the practical skills that we need to use in our teaching methodologies. So let us inform others to continuously join. My secretary, the ICT professor, Mr. Rogers, I wonder if you have something to mention. Otherwise, I'm grateful. Rogers, do you have something to add on what I've said?
Yeah, that is okay for now. We just need to maybe, we are going to have the flyer ready early. Members, we shall try to share so that more people can join next week. Whereas we do the recordings, it's also good to have the direct interaction. So let us share so that next week we are on. Thank you very much.
Thank you very much, Rogers, and thank you very much, everybody. May we pray that God, who started with us this meeting, has ended with us this meeting and will give us a blessed night. Good night, everyone.